Is that working?
Yeah.
Thanks all.
Yeah.
Am I on there? Magic, thanks. Okay, cool. Hi, so I'm Mike. I'm here from Cannybots to talk to you about Cannybots through 3D printing and Raspberry Pi. So, first, as I say, I'm going to tell you about 2 bots, going to tell you who's using them, what they're using them for, whereabouts they're being used, what's being done with them, and show you some examples of how to use the Raspberry Pi with the Cannybots. And then at the end, there could be some dancing. So what are they? They're these. They're small 3D printed open source toys. These are line following robots that we race around some tracks. They're open source, hackable. You can program the insides of these bots. You can take the 3D designs from online, modify them and change them. But what I'm going to do is I'm going to show you a quick video of them in action. So, those are our little Cannybot races. What's inside them? I'll tell you what's inside them. So, that's an exploded diagram of a Cannybot. We've got 3D printed chassis. We've got silicone wheels. There's a battery switch. Some metal gear motors. And in the core we've got our custom electronic module, which is called the BlueBrain. That's a Bluetooth module, so Arduino compatible, and you can talk to it from a Pi using a Bluetooth dongle. So the BlueBrain itself we use for line sensing and it's got an onboard motor controller to drive the 2 motors. It's actually got over 20 inputs and outputs, so you can use it to connect to other things like servos, LED lights, I2C devices. There's a whole host of things you can do with it. I've got a quick video of a Cannybot being printed. I don't know if any of you have seen 3D printers in action. I've got a time-lapse video of one of our chassis being made. So the way 3D printers, this particular type of 3D printer, the way it works is it squeezes out molten plastic layer by layer, building up. And here's building up one of our chassis of our bot. And our Cannybot orange, we like to call it. Quite like the orange. So as each layer is built up, the platform raises down, and then at the end, we get a new toy to play with. Put the BlueBrain in, put our kit in, to then control and have some fun on the tracks. Not just the tracks. What we've also got. So, why did we create Cannybots? We wanted to create something that was fun, educational, and very engaging for children to learn to program. It's physical computing. We wanted to cover more than just the programming element. We've got mechanics involved, 3D design, so DT. There's some electronics. There's also artwork as well, so you can customize these bots as well. So we think we're cross-curricular, cover a few aspects. I say there's the programming and then the art and science side of it as well. We sell them in kits, so we want children to make them and understand them from the inside. We want to demystify tech. So it's like it's not a black box. You can understand it, you can play with it, you can have a lot of fun with it. Not only that, if some children may want prefer the programming element, Some may prefer the design technology side of it. So with children working in teams to some will do design work, some will do some electronics, and then some will do the programming. And then they can customise their bot and possibly compete against other children. They might be doing racing and things, changing the size of the wheels or different aspects of the bot. So there's an element of competition involved as well, should they want to. So we find a lot of people currently using them. We've got makers out there, Brian here himself uses them. A lot of teachers around the country and also US and other countries around the world are using them. Co-clubs in the UK. There's a 3D design club being set up, or has been running in Wimbledon, where some teenagers are taking our open source designs, modifying the chassis, printing new bots, and playing with them. Parents are good fun that way, and parents, they like them, and educators as well. So how are they used? So we sell some tracks. We sell a racing track. The top left there, time trials, just 2-player fun. We've got from the racing, there's an educational side, it's the maze solving in the top right. So on that you can control the Cannybot from a Pi. The Cannybot will say, I found a corner. That information will go across the Pi, and the Scratch or a Python program can determine what to do next. And send the information back to say turn left or turn right. Then we've got some other fun things like sumo wrestling, bot to bot, turf it out, and some performance drag racing elements. But so that's the things that we've got provided. But it's just not limited to that. You can take the line following and use it on using black electrical tape. Some people have printed their own tracks. There's some resources online where you can download your own customizable tracks, print them out on A4, stick them together, get as big as you like. There's PyRobot. So we've got people doing their own tracks, people taking the 3D designs to the top left, changing them to the DT aspect. Someone's taken the BlueBrain and completely changed it, made a hovercraft. That bag's actually a Tesco freezer bag. Completely new projects. I said Brian's PyRobot, Pi was last year. Someone's done a Minecraft integration, so they're taking our software, keeping the Cannybot it is, but taking the software side off in a new direction. More fun thing, Minecraft's very popular with children these days. Another side project we've done is a logo turtle. So there's a Pi on an HDMI Pi screen in the background and a little logo turtle teaching geometry, navigating around with the commands. So how do you use them yourself if you want to do it yourself? So with a Pi, you can use Scratch, Python or Sonic Pi to send commands over Bluetooth to a Cannybot. You can simulate a joypad, you can send a maze command. You can change the code on both sides and set whatever you like to do, whatever you need to do. We've got an Xbox controller integration, so you can connect one of the Xbox controllers to the Pi and then forwards them onto the bot for doing multiplayer racing. So that's some supported language. You can use it in many other ways. Here's an example of Scratch. So what happens is, when the bot's on a maze track, you'll follow the line. When it comes to a corner, he'll stop. And he says, I found a corner, and he'll send, is it left, is it right, or is it T-junction? That comes to the Pi. In this case, the Scratch program says, is told, I found, in this case here, I found a right turn, maze up. Simply in this case, what we're saying is, okay, turn right. So that then sent back to the bot, and the bot will go its merry way. On the left is the full maze navigating program. When he finds a left, goes left, finds a right, go right. But if he finds a T-junction, he spins a coin, goes left or right, depending if it's bigger or less than following. So we've got Scratch integration with Pi. We're doing some more interesting things than racing. We've got Python interface on the Pi. This is say the minimal example of how to send joypad commands to a Cannybot using Python on the Pi. We've got some custom libraries. One of them is pure the base level communication. And we've got another library that knows how to send joypad messages to the bot. So here we're saying connect to the first Cannybot available, and I'll go into how that's configured behind the scenes in Node-RED later. We've got a helper for sending those commands. And this example here is something, go full speed for a second, then stop. So there's an example of our Python integration support on the Pi. We haven't got Ruby libraries yet, but this is demonstrating how you can call our underlying what's called a WebSocket interface, which is how Scratch and how the Python libraries are working. So for languages we haven't got immediate support for, Ruby or Java, for example, this is the bare minimum you need to do to send a message to a bot to turn right. So with that you can use your favourite language of choice. And we're using this in our Sonic Pi demo later. So that covered everything on the side of the Raspberry Pi. Inside the bot is an Arduino compatible microcontroller. So this is an Arduino sketch. This is the smallest sketch you can run on the bot that listens for those joypad commands and responds appropriately. So at step one there, we've got start the Bluetooth. This is my name. We've then got some variables for recording the joypad values that are going to come across the Bluetooth link. In the Arduino setup, we've got some basic setup to say, if you get the joypad values, update me. And then in the main loop, we're converting those joypad values that have been received into the motor commands that control the bot. So that is a working example of a Cannybot running along the ground and control from your Pi. So I've touched on some of this. So under the hood, Scratch has got a little software agent running because it can't talk natively to WebSockets. Python and the Sonic Pi stuff is using WebSockets to talk to a Node-RED server that runs on the Pi. And this Node-RED part that hides and configures the Bluetooth connection to all the Cannybots. So with that WebSocket interface, as I mentioned before, you can use other languages of your choice. If you want to. This is an example of Node-RED workflow. I won't go too much into it. We've got a number of online resources. You can download the code. This is SD card image with all this installed, pre-installed. We've got some help setting up and how to determine if your Bluetooth USB dongle work with Cannybots. These are a newer version called Bluetooth LE, Bluetooth version 4. We're active on the forum, so if you've got any questions, we can answer them. So the next thing is a demo of them dancing. So with a bit of luck, you'll see them. This is a Sonic Pi integration. We've got some music playing, and we're sending messages to the bot to do some moves. So, okay. So if you could put on my please. It's okay. That shouldn't wake me up.
So rather than follow lines, that's actually just sending commands to move motors, and I use
That's right, yeah. It just sends, it's using the maze sketch to say, turn right a bit, turn left a bit. Yeah, and it's not mindful at all. So this is what it should look like. There we go. So that's the little dancing robot. So I'm fastly running out of time, but actually that's the end of all this presentation. So, yeah. Thank you very much.